Hello, dear students. Have a nice day today. So, today we are going to start the most important chapter of the plus 2 second year 12th class, that is application of derivative. So, before that, I hope you know the different types of methods to find the derivatives of different types of functions. The continuity, differentiability and the differentiation you know very well, because you see, if you not know properly about the derivatives, then the name of the chapter is application of derivative. So, my question is here, if you don't know about the derivative, so what application will do? So, if you not know any concept or if you are forgetting any concept of the derivative, so you can make it off before coming to the chapters or during the chapters. So, in this chapter, we will see so many applications of the derivative. The application of the derivatives used in the various field in our day to day life. The vast application of the derivative, I can say, in the engineering, in science, in social science, in finance, in public sector, everywhere the derivative is used. So, without a derivative, they cannot move a step again. So, try to understand the importance of this chapter and what exactly we will discuss under this chapter. So, first off, I am writing what are the articles or what are the subtopics are there inside the chapter, then we will discuss one by one. So, in this chapter, what exactly we will know? The first we will see rate measure. Rate measure. Please write down what to be covered in this chapter. The second will come to tangent and normal. Tangent and normal. The third article will come to increasing and decreasing. Increasing and decreasing. Then fourth we will see approximation and error, means error and approximation. Error and approximation. Then the fourth, then the fifth, the most important, maxima and minima. Maxima and minima. Then the sixth I can say application of maxima and minima. So, once again please note down. Then seventh I can say here MISC, miscellaneous problem. So, please note down what we will discuss. So, in this chapter, the big chapter we can say and a very important chapter. First one is rate measure. Second one is tangent and normal. Third article will go increasing and decreasing of different functions. Then the fourth one will move approximation and error, which is highly used in your physics. Maxima and minima, the concept of the maxima minima you know in the previous classes, but we will see how the derivative is helpful to find out the maxima and minima of a function and the application of the maxima and a minima. And some miscellaneous problem means comprising all those articles, those problem will discuss that is called the miscellaneous problem of this chapter. So, this is the lead of this chapter. So, during this chapter it will be my request to everyone, please go through each and every subtopic thoroughly. If anybody having any doubts anywhere, you can ask the questions to me and clarify the doubts whenever we get the chance. Okay, out of these articles or the subtopic, today only discuss the rate measure. The subtopic of the application of the derivative, that is rate measure. Today I am going to discuss about the rate measure, and the word rate measure is not new to you, because you know the rate measures in your physics. You have started this one from the standard 9, I can say, in the mechanics, in the chapter motion. So, what is rate measure? Rate measure means the change of a parameter with respect to another parameter. I can write here the change rate of change of a parameter with respect to another parameter. The very simple definition of rate measure with respect to another parameter. Then question arises, how you know? You know very well. You know about the velocity. Velocity, what is velocity? That is the rate of change of displacement. The rate of change of displacement, that is called ds by dt. That is the rate of change of displacement with respect to time. That is the velocity, you know. Similarly, if you like tell about the acceleration, what you know in the mechanics, acceleration, rate of change of the velocity, dv by dt. So, if I will analyze these two, so what does it mean? The meaning is, suppose one body is moving and it is covering some distance. So, we will find here the change of the distance with respect to change of the time, that is your velocity. Similarly, here acceleration. What is acceleration? Because when one body is moving, the velocity also changing. If the velocity is changing, the rate of change of the velocity with respect to time, that is your acceleration. So, these two things already you know in your physics starting from class 9, 10, 11, 12, and when you are coming to the class 12 and when your physics chapter starts, the mechanics, the physics teachers might have told about the derivative, because without derivative and integration they cannot teach the concept of the physics, particularly in the mechanics. So these are the things that you already know. Let us come to your mathematics. What the mathematics says? What is the mathematics says? Suppose how this derivative is related to rate measure or rate of change of something. Let the change of the parameter y with respect to the parameter x with the relation, because they must have a relation, with the relation, say y is equal to f of x. Once again, let the parameter y changes with respect to the parameter x with the relation, because the relation between the parameter y and the parameter x is like this: y is equal to f of x. Then we can say the change of y dy with respect to change of x dx, that is nothing, that is the derivative of the function, that is f dash x. And if at a particular point I will choose, suppose I want to find that change of the parameter y with respect to the parameter x at a particular point x is equal to x0, then I can write dy by dx, this symbol is at x is equal to x0, that will be called as f dash x0. So, my dear students, what derivative we are reading? So, derivative is nothing. The another definition we can say, the rate of change of the parameter y with respect to the parameter x, where both the parameters y and x as related with a relation, that is y is equal to f of x, then this change of y with respect to x is dy by dx, that is equal to f dash x. Or at particular point if I will take, then it will be dy by dx at x is equal to x0 is equal to f dash x0. So, some more application of the derivative we can discuss like this way. A rocket scientist need to compute the precise velocity with which the satellite needs to be shut down from the rocket by knowing the height of the rocket at various times. That means the rocket scientists, they are using the concept of the derivative to sort out from the rocket by knowing the height of the rocket at various times. This is one of the application it may be. The second application it may be, the people maintaining a reservoir need to know when will a reservoir will overflow by knowing the depth of the water at several instant of times. The different dams the people are using, by using the derivative they can able to know at what time the reservoir will be overflow, and accordingly they will give the information or they will take the precaution for the benefit of the society and for the people. In the financial sector also it is highest applications are there. Financial institutions need to predict the changes in the values of a particular stock knowing its present value. Then other applications are like this. So, the derivative can be applied in the stock exchange about the marginal cost price and marginal revenue. Marginal cost price MC, capital M, capital C, and marginal revenue, capital M, capital R. So, these are the some applications of derivative. So, this is a very interesting chapter indeed, because so many applications we can do by reading this chapter thoroughly. Okay. So, students, see how to attempt the questions based on rate measure. So, I am telling some steps or algorithm. The first point you write down. I am writing the steps or algorithm. Write down steps or the algorithm. Algorithm. How to solve or how to appear or how to solve the problem related to the rate measure. Point 1. Point 1. Find the function. Find the function from the question. Because here maximum word problems will be there. So, in the word problems, you will find the name of the function, because without function we cannot move anything. First you write down, then I will tell when we will solve the problem, I will tell how to use the step 1 and how to use the step 2. Second, check what are given, and what to be find out, So, second point, check what are given. So, what will be given, that must be in the form of D, means change of something by change of something, with respect to change of something. And what is asked also, it is in form of the derivative also. So, what will be given, that will be in the form of the derivative, in the form of dy by dx, and what is asked also, that is in the form of dy by dx. And thirdly, make one relation, before applying the derivative, find a relation between the given and asked. Find the relation between the given and between the given means what is the given question and what is asked, and what is asked to find out, and thereafter you will use the derivatives. So, once again I am telling, my question is, please read this question thoroughly. Very simple method I am telling. Find the function, because the function will not be given there. For example, I am telling, say, suppose a round spherical balloon inflated at the rate of, say, 9 cubic centimeter per second. That means it is given the round spherical balloon, means it is a sphere. So, the sphere, the volume of the sphere inflated means what will be inflated? The volume will be inflated. So, it is cast that the volume of the sphere is the name of the function, and the dV by dt is given, say, 9 cubic centimeter per second, like this. And suppose it is asked, at what rate the radius must increase at an instant, radius is equal to 2 centimeter. At what rate the radius will be increased, means what is asked? It is asked dr by dt, asked. So, once again I am telling the question, I am giving a simple question to you. Suppose a round spherical balloon inflated at a rate of 9 cubic centimeter per second. Means here it is given that the spherical balloon, the balloon is looking like sphere. So, the name of the function is volume of the sphere. So, the volume of the sphere is equal to, volume of the sphere V is equal to 4 by 3 pi r cube. Name of the function. And what is given? Now, the balloon is inflated at the rate 9 cubic centimeter per second. And what is asked? At what rate the radius of the balloon is increased, and an instant means some another data is given at a 2 centimeter. So, by listening the question, the first the volume of the sphere, it will be cast from the question. What is given? Now, the inflated at the rate, means the volume is inflated, means dV by dt is given 9 cubic centimeter per second. What is asked? At what rate the radius is increased at an instance, radius is equal to 2 centimeter. Meaning it is asked to find dr by dt. So, if you will keep the relation between, and the last point I have given, find the relation between the given and asked. Given is dv by dt and asked is dr by dt. So, you will use the application of the derivative, you will use the derivative in the both sides and you will get the answer. So, this is one sample question and sample answers I have given orally. By using those 3 points, we can answer any type of questions related to rate measure. Okay, discuss some questions related to the rate measure. So, write the question number 1. Question number 1 is like that. Find the rate of change of the area of a circle. Find the rate of change of the area of a circle with respect to its radius, where radius is 5 centimeter. It is a 1 mark question. It is very easy question. It is very easy question. Let us see how it is solving. The question is asked, the question number 1 I am writing, area of the circle. So, the area of the circle is the name of the function. A is equal to pi r square. And what is asked? It is asked the dr by dt. And what is more information given? Now, r is equal to 5 centimeter. So, once again I am telling the question, find the rate of change of the area of a circle with respect to the radius. So, with respect to the radius it is asked, so it is not required. So, radius is already given 5 centimeter. So, it is very simple, I am telling it is carrying 1 mark. So, find out dA by dr, that is equal to pi r square 2 into r. So, pi 2 into r is given 5. So, 5 into 2, 10 pi. So, dA by dr. So, this is the dA by dr, the rate of change of area with respect to the radius is 10 pi. Okay, this is the 10 pi. This is the simple answers to you. So, write the question number 2. The question number 2 is like this. The volume of a cube is increasing at a rate of 9 cubic centimeter per second. The volume of a cube is increasing at a rate of 9 cubic centimeter per second. How fast is the surface area increasing when the length of an edge is 10 centimeters? So, please see the question, read the question carefully and tell me what are the data is given to here. So, here the volume of the cube is increasing. So, question number 2 write down, the volume of the cube is increasing. So, the volume of the cube is the name of the function. So, what is given? So, volume of the cube, write down, volume of the cube. Volume of the cube you know, that is x cube, V is equal to x cube. So, what is given? Now, volume of the cube changes at the rate 9 cubic centimeter per second, that is given. The volume of the cube increases at the rate 9 cubic centimeter per second. And what is asked? What is asked? Now, at what rate its surface area increases? Surface area means total surface area. So, what is the total surface area of a cube? 6x square. So, here I can take x is length of each side, that we have to mention. So, what is asked? Now, surface area, let S be the surface area. So, ds by dt it is asked. So, remember the algorithm what I have given to you. First I told find the name of the function. Name of the function is got volume of the cube. b is equal to x cube, where x is given, x is the each side of the cube, and the value of the x is given here, x is equal to 10 centimeter, the instant value is given. So, let us come to here. So, once again the data, the volume v is equal to x cube, name of the function, second dv by dt is given, then the third ds by dt we are going to find, and the instant value of each side of the cube is also given. So, let us come to here. So, v is equal to x cube differentiating with respect to x, with respect to t, time. So, it will be dv by dt, x cube 3x square, then by using the chain rule dx by dt. So, dv by dt is equal to 3x square dx by dt. So, I need suppose dx by dt, because dv by dt value is given 9. So, 9 is equal to 3x square into dx by dt. So, carry on like this way. So, carry on like this way. So, what is the value of dx by dt? Now, dx by dt is equal to 9 divided by 3x square, that is equal to 3 by x square. The value of x is already given 10. So, I can write 10 square. So, 3 by 100. That means dx by dt is equal to 3 by 100. I got. That is not the solution of the problem. On the way, I got dx by dt is coming 3 by 100. So, I can write is 0.03, but I am writing 3 by 100. But what is asked? It is asked to find the rate of change of its surface area. So, surface area means total surface area. So, it is asked to find the surface area. Surface area S is equal to 6x square, and we are going to find ds by dt. So, differentiate with respect to t. So, ds by dt. So, 6 into 12 into x into dx by dt. Correct? Derivative of s with respect to time, ds by dt. So, 6 is there, x square derivative is 2x, 2 into 6 I written directly 12, x dx by dt, and the value of the dx by dt is given, value of the x is given, put the values. So, 12 into x is 10 into 3 by 100. So, 0 is cancelled, 12 3 36 by 10. Once again, 12, the value of x is 10 into 3 by 100, 0 0 cancel, check whether any calculation mistake. So, 12 3 is 36 by 10, so 3.6, and the derivative of the surface area, it is your square centimeter per second. That is, therefore, I can write finally I can write ds by dt is equal to 3.6 square centimeter per second. That is not because the surface area is square centimeter per second. Okay, let us go to another problem which is from the textbook, that is the miscellaneous of the textbook, and the page number is 235. Okay, the question is like this. The question is example 44 of the NCERT book. So, read the question and see the question. A man of height 2 meter walks at a uniform speed of 5 km per hour. A man of height 2 meters walks at a uniform speed of 5 km per hour away from a lamp post which is 6 meters high. Find the rate at which the length of the shadow increases. Once again, a man of height 2 meters walks at a uniform speed of 5 km per hour away from a lamp post which is 6 meter high. Then what we are going to find? Find the rate at which the length of his shadow increases. So read this question twice, then you will solve it. So question you read twice, then you will solve it. Okay, I am only writing what are the data given here. Question number 3, the man of height 2 meter given and a lamp post is here. So let us see, this is the lamp post suppose. The man is moving in this way and the height of the man is given like this way and the shadow is casted here. So I am writing, say PQ is the man. This height is 2 meter given and say AB is the lamp post. So what is the amount given here? Yes, 6 meter given. And say let this point is suppose PQR. Look at the figure. Look at this figure. So in the figure we can write AB is the lamp post. Write down AB is the lamp post and PQ is the height of the man. Write down PQ is the height of the man. So here write down solution. Here AB is equal to lamp post is equal to 6 meter given. PQ man which is given 2 meter and the man is going away from the lamp post. Let us say I am taking this one is X and this is Y. So what we have taken X? Now let BQ is equal to X and QR is Y. So once again you read the question. The question is the man is moving away from the lamp post at a speed of 5 km per hour. Means the man is starting from here and going there. That means dx by dt is given to us. So what is given to us? dx by dt 5 km per hour. And if the man is here, so obviously this will be the shadow and the shadow length we have taken y. So what we are going to find? Now dy by dt. So it is asked to find dy by dt, it is asked to find. So you see this is a very nice figure that you have read in the class 10. So here the triangle ABR and PQR are similar triangle. So I can write here triangle ABR similar to triangle PQR. By using the concept of the similar triangle, I can write here AB by PQ. AB is for the big triangle, should be equal to BR by QR. BR, the length is x plus y, and QR, the length is y. Just put the values, then you will get one relation here. AB, how much? 6. PQ, how much? 2. BR is BQ plus QR, x plus y, and QR, y. So cancelling, it is coming 3. So what we are getting? Now 3y is equal to x plus y, or you are getting x is equal to 2y. So we got x is equal to 2y by the relation and applying the concept of similarity of two triangles. So we got x is equal to 2y. So x is equal to 2y is the name of the function. So differentiate with respect to time, with respect to t. Very easy. Dx by dt is equal to 2 dy by dt, and dx by dt value is given to us, and dy by dt is asked to find. Put the value of dx by dt. Dx by dt is given 5 is equal to 2 dy by dt. So dy by dt is equal to 5 by 2 kilometer per hour. So this is the answer. That means very simple. By using the concept of the similarity, we got AB by PQ is equal to BR by QR, and by the way we got a relation between x and y, that is x is equal to 2y, and we have differentiated with respect to time. So dx by dt, and finally I got dy by dt is equal to 5 by 2. So what will be the answer, final answer? The final answer, therefore the shadow of the man increases at the rate of 5 by 2 kilometer per hour. So these 3 questions I solved, and some assignment I am giving based on the rate measure, and I hope all will try your best to solve the problems. If you are finding any difficulty, then you will not hesitate to ask me in the next class. So thank you very much. Thank you for patience hearing. Thank you.